All right, let's go ahead and get started with our next video. This video is going to be for Stat 210, handout number 7, and we're going to be covering pages 1 through 10 here. All right, let's go ahead and get started. So what we're doing with handout 7 is looking at relationships between categorical variables. So what do I mean by that? Well, let's consider our case study here for handout number 7, at least the first case study. And what we're going to be looking at is whether or not people that work in a particular factory have airway obstruction. So I'm going to record the numbers that do have airway obstruction and the number of people that do not have an airway obstruction. So that's one of my categorical variables, whether or not they have an airway obstruction. The other variable that I'm going to be taking into consideration is whether or not they're smokers. So do they smoke or not? So I want to know what the relationship is between their smoking status and whether or not they have an airway obstruction. So both of these variables are categorical in nature. They have categorical levels. You're either a smoker or a non-smoker, and you either have an airway obstruction or not. What's provided here in the table on page 1 of handout 7 is just the counts for the number of people in each of those combinations. So here I can see that I had 8 smokers with airway obstruction. I had 56 smokers without airway obstruction. Likewise for the non-smoking row here. Over here in the totals, or in the margins is what we say, we have 64 people total that were smokers, and I had 52 people total that were non-smokers. The margins in the columns here, so I had 21 total people that had airway obstruction out of a total of 116 people, and I had 95 out of 116 that did not have airway obstruction. Now to get this data into JUMP, what I need to do is just identify the two variables, so smoker, either yes or no, and airway obstruction, yes or no. And then I want to take that information about the number of people and put that into a column called counts. So I'm going to go ahead and pause here for a moment, and I will let you get that data typed into JUMP. Okay. So how do I go about doing the analysis? So what I'm going to do now, because I have two variables, is I'm going to be selecting Analyze and then Fit Y by X. The airway obstruction is going to go in the Y response box, and the X factor box, I'm going to put smoking status. Now we need to differentiate between these two variables. The response variable is the primary variable that I care about, so whether or not they have an airway obstruction. The X factor box, okay, contains the other variable, and that there is just how my groups were determined. So you can kind of think as the smoker as what my two groups are here. They're either the smokers or the non-smokers. Now when I make these tables, I always put the grouping variable as the rows and the response variable as the columns here. So in all of my notes and my discussions, I'm assuming that you're doing the same. So let's go ahead and set this up. Analyze, Fit Y by X. I'm going to put airway obstruction in the Y box and smoker here in the X factor box. Now, as I've said before, right now JUMP just thinks you have 1, 2, 3, 4 rows in your table. You need to tell JUMP that you want to use these counts in your analysis. And we do that by putting count down here in the freak box. So again in the notes there, on page 2, notice that I have count here in the freak box. Now when I click OK, I'm going to get kind of 3 sets of output. I'm going to first get output regarding a graph here on the top. I'm also going to get output regarding what we call the contingency table, which is going to have 2 rows in it and 2 columns in it, which is essentially the table that we had initially up above. And then I'm also going to get output that deals with the tests. So once you click OK, you're going to get what we call the contingency table. So let's go ahead and click OK and look at those values. So now I'm back over here in JUMP, As I said, you can get the Mosaic plot, or just the segmented bar graph, I guess is what that would be. I get the contingency table here, and I also get the testing output. Now the contingency table provides not only the counts, but lots of other information. So let me just for the moment take that other information out. So total percent is going to go away, column percent is going to go away, and row percent is going to go away. So this is the same table that I had initially in the notes there on the top of page 1. Oops, let's go ahead and go back to the notes here. So for the non-smokers, how many of those did not have airway obstruction? That was 39. Of my non-smokers, how many had airway obstruction? That was 13, for a total of 52. And then likewise for my smokers. Now, in order to break down relationships like this, so the title of this handout is called Relationships Between Categorical Variables. How we do that is with the idea of conditioning. So what I'm going to do here on page 3 is condition on my non-smokers. So what I mean when I say condition on my non-smokers, I'm going to ignore all the other combinations or all the other levels for that variable, which here there's only non-smokers and smokers. So I'm only going to isolate on that first row. Now what kind of summaries can I do on that first row? Well, I can compute percentages. So for example, I could ask how many of my non-smokers have an airway obstruction? Well, there were a total of 52 non-smokers and 13 of them had an airway obstruction. So I could quite simply, on my calculator or phone, take 13 divided by 52. That would give me the percentage of my non-smokers that had an airway obstruction. And that is 25%. And those are computed by what's called the row percentages. So if you want these row percentages in JUMP, all I got to do from my contingency table is ask for row percent here. Again, I'm on my contingency part of the output, the red drop-down menu, and I can just ask for row percent. So how those values are computed again is just taking that particular number, which was 13, divided by the total there of 52. Likewise, 39 divided by 52 would be 75%. So what does this mean again? What's the interpretation of this 25%? Well, 25% of my non-smokers had an airway obstruction. I could create a graph for that, just a segmented bar graph here. The top portion of that output is going to be for my airway obstruction. We'll look more at those graphs in a minute. Now that I've looked at the percentage there for my non-smokers, what I'm going to want to do is look at that same quantity for my smokers. So for my smokers, I had a total of 64 of them, and 8 out of the 64 had airway obstruction. So 8 divided by 64 is going to be 12.5%. So when I'm trying to understand the relationship between smoking status and whether or not they have an airway obstruction, I'm going to want to compare this 25% to this 12.5%. Again, what do these numbers indicate? This says for my non-smokers, the rate of airway obstruction is 25%, whereas for my smokers, the rate of airway obstruction is only at 12.5%. In the context of this example, what that means, if we go back up and look at the initial story here, this was asking about the rate of airway obstruction for people that work in this particular factory, which is a production plant here. And the rate of airway obstruction is substantially higher for my non-smokers than it is for my smokers. Again, those rates were 25% for my non-smokers, whereas my smokers only had a rate of 12.5%. So at least for the data that I've collected here, it looks like the effect of this production facility is substantially larger for the non-smokers than it is for the smokers, at least when we're looking at whether or not they have airway obstruction. So on the bottom of page 3 here, we have a summary. Again, there's that 12.5% and that 25%. If we look at it on the graph, okay, on my non-smokers, so that's the left side here, that corresponds to that top row. I had 25% of the individuals in this group had an airway obstruction. So you can really think of this, let's go ahead and just put kind of a dividing line here, into two pieces. The information on the left of my dividing line is for my non-smokers. The information to the right is for my smokers. The gray box here, as indicated on the margin on the right side, is for those that have an airway obstruction. And again, that's 25% here. Oops, sorry about that. That's 25% for my non-smokers, whereas that rate falls substantially lower. It's only at 12.5% for my smokers. So what we really can do here is just look at the size of this gray box on the left versus the size of this gray box on the right. Again, the gray box is for those with airway obstruction. We can see that the size of the box for the non-smokers is substantially larger than the size of the box for my smokers. So again, indicating that at least when it comes to airway obstruction, the effect of that production plant is very different across my non-smokers and smokers. Normally, we would think that smokers would have a bigger problem with airway obstruction. But this production facility must have some kind of adverse effect here on the non-smokers in order for that rate to be so much higher. All right, let's go ahead and look at a second example. This data is about low birth weights, so low birth weights of babies. And you can get that data from our course website. So I went ahead and already downloaded that, and let's open that. So the information that I have in this data set, we can see over here by the number of rows and columns here. I have a variety of columns or information here. I got the race of the mother. Okay, I got information about, has this mother given birth previously and had a low birth weight baby? So no means they have not had a low birth weight in the past. This individual here, this woman here, has had a low birth weight baby in the past. We also have information about whether or not they're a smoker, uterine irritation, and also the mother's age. Finally, we also have the weight of the baby, and this is in grams here. Now, this is a study about low birth weight babies. So in order to identify whether or not a baby is of low birth weight, we're going to use that threshold value of 2,500 grams. So that 2,500 grams is widely accepted as an indicator of whether or not the baby is of a low birth weight. So I need to create a new column here called weight, which is going to be normal if it's 2,500 or above, or for example here, it's going to be indicated as low if it's less than 2,500. So let's go over into Jump and create this new column called weight. And we're going to need a formula that uses this conditional statement to identify whether or not it's a low birth weight baby. So we're going to add a new column over here. Going to label it weight. And now I need to do that formula. This is going to be a conditional formula. Going to be selecting an if statement here. So again, I'm under conditional, and then that if statement. I need to do a comparison here, so I'm going to say comparison. A less than B is the one I want to select here. And I want to know, quite simply, is the weight in grams less than 2,500? If it is, I'm going to indicate that as a low birth weight. I need double quotes on that as well. So indicate as low there. And if it's not less than that 2,500, we're going to indicate that as a normal birth weight. So again, you need those quotes there. We're checking it against 2,500. Go ahead and apply that. Click OK. And hopefully that new column gets created. Now, Handout 7 is about comparing one categorical variable against another. So now that I have my information, which is weight, listed as a categorical variable, it's either going to be normal or low birth weight here. I'm going to make comparisons now of weight against race, or weight against previous history, or weight against smoker. So these variables here, the race, previous history, hypertension, smoker, uterine irritation, are all potential what we would call risk factors for whether or not a mother is going to have a low birth weight baby. So we might want to look at, well, which of these risk factors is most important in predicting whether or not a mother is going to have a low birth weight baby. So through the analysis that we're going to do here in Handout 7, we can identify that. So let's go back over into Jump now. I'm going to select Analyze, Fit Y by X. So Analyze, Fit Y by X. My primary outcome here is of low birth weight, and I'm going to be making comparisons there across all of these variables: race, previous history, hypertension, smoker, and uterine irritation. So we'll drop all of those in the X box there. So again, we can look at multiple of those. And what that's going to do is just create several Mosaic plots. This one here is for race, as you can see in the label or in the title here. So this is looking at weight, which is of low birth weight or normal, across race. This one to the right there is looking at weight versus previous history. So on the x-axis here, I got previous history. If I move to the right there, I got hypertension, smoker, and uterine irritation. I also get all the contingency tables. So that has all that information about the row percentages and the counts, and I also get information about the tests. So let's go back here in the notes. You can see all of those have been collected here on page 5. So I put all of those all on one page here on page 5. So this is looking at all the risk factors kind of simultaneously. The white boxes are the low birth weight here. The normal is gray. So this time I actually want to be looking at the white boxes. So certainly we can see that the non-whites here are on the left side for race. This 39.6%, what that means is that about 40% of non-whites are going to end up with a low birth weight baby. So white boxes indicate low birth. About 40% of the non-whites were of low birth, whereas for the whites, that drops clear back to about 25%, 24.2%. So we can definitely say that non-whites are more likely to end up with a low birth weight baby than whites are. Previous history here, we can see that those mothers that had a previous history are much more likely to end up with a low birth weight baby than mothers with no previous history. So again, 60%, it looks like, of the mothers with previous history ended up having a low birth weight baby. For mothers that had no previous history, that drops back to about 26%. Pretty substantial difference here between whether or not a mother had previous history and not, and whether or not the mom was going to end up with a low birth weight baby. So previous history here is going to be an important risk factor. It is fairly predictive in whether or not a mother is going to have a low birth weight baby, because there is such a substantial difference between what I'm seeing on this side versus this side. Now, one reason that this column is so wide is because most of the babies, okay, or excuse me, most of the mothers had a no on previous history. So if I go back and look at the actual data for that, I'm looking at previous history here. Let's go ahead and look at only the row percentages. So previous history, no. That's going to be that first row. 156, previous history, no, was the total. Whereas for yes, it was only 30. So I didn't have very many mothers that had previous history, only 30. So what is 30 divided by 186? 186 was the total there. Only about 16% of the babies were of low, only about 16% of the mothers had a previous history. So this column right here is 16% of the width. This other column would be the 84%. So again, the width here just indicates kind of an idea of how many people are in this group relative to this group. On the race, it looked much more balanced. Looked like we had about the same number of non-whites and whites. Maybe slightly more whites because it's a little bit wider, but it's fairly balanced. If you go back and look at those totals, it was 91 and 95. Okay, so again, pretty close there in the totals. So those two columns are going to be about the same width there. All right, let's get back to comparing whether or not I have good predictors. Hypertension, it's a slightly bigger here for the high hypertension. Excuse me. Smokers is somewhat predictive. For my non-smokers, they do have an increased chance of a low birth weight baby. Uterine irritation, again, that's slightly larger there. If we kind of scan across all of these, again, the biggest separation or biggest difference looks like previous history here. So previous history seems to be the most important risk factor when trying to differentiate whether or not a mother is going to have a low birth weight baby. So what are we doing here on page 6? What we're doing on page 6 is looking at mother's age. Okay, so I can't initially use mother's age when looking at the relationship here because I need, or what handout 7 is for, is whether or not, handout 7 is to compare two categorical variables against one another. So I can convert a numerical response and jump into a categorical by using the utilities menu here. So if I go under columns, utilities, make binning formula, follow the steps that are here on page 6, okay, that is going to create bins for you. And once you do that, you'll get these bins out. Like this mother was between the ages of 20 and 30. This mother here was between the ages of 10 to 20. Once you have those, then you can go ahead and create a mosaic plot with the binned age. So here we can see mothers that are between 20 and 30 have an increased risk of low birth compared to others. It's 36% here. If you go to mothers that are between 30 and 40, the rate of low birth drops down to 15%. So that's binning on a numerical variable. You first got to convert that into categories. All right, real quickly, let's look at a local data filter. So what we are doing right now is let's look at previous history against low birth. I'm only considering those two variables. But I can bring information about a third variable in through the use of a local data filter. So let's show you how to do that. So let's look at previous history. All right, and I'm going to do smokers versus non-smokers. All right, so let's look at the Mosaic Plots. for previous history against low birth, and then I want to take into consideration their smoking level. So again, this is going to be on page 9. So here I'm actually conditioning on two things. So my goal here is to understand low birth weight. I'm going to condition on previous history, but I'm also going to condition on whether or not the mother was a smoker. So this is going to allow me to look at combinations of things. So let's go back to, let's kind of start over here. So I'm going to go back to Analyze, Fit Y by X. I'm going to be looking at weight here, and then I'm going to do previous history. Okay, this is the Mosaic Plot that we've been looking at. I can add those percentages in there by doing a right click, cell labeling, show percents. Get there eventually. So there's that 60% and that 26.3%. You can change the colors of these if you want by set colors. I think in the notes the blue is actually gray and the low birth was white. So there's that 26% and that 60%. Now what I want to do is get a breakdown of this information. Okay, I want a breakdown of this information on smokers and non-smokers. So I want to take that into consideration as well. So from the drop-down menu here, red drop-down arrow, excuse me, I'm going to select Local Data Filter. And let's go ahead and do that on smokers. Say Add. And now if I click on just the smokers, what that's going to do is break down and look at just my non-smokers. So I said smoker equal no here. If I go back to smoker equal yes, so I can select between these two groups here by just using my local data filter. So let's look at the non-smokers for a minute. For my non-smokers, the discrepancy between previous history is at 22.8 versus 50%. This box looks like it's about 30% higher, 28% higher. If I select my smokers though, okay, I can see, well, one thing that I can see is that both boxes move up a little bit. So let's go to smokers. You can see that this one increases and also this one increases. So for my smokers having a previous history, that chance of a low birth weight baby jumps up to 2/3 here. It's quite large. Okay. If I look at that for my non-smokers, it drops back to 50%. So this is a nice way to look at, well, I'm looking at 3 variables at once. I'm looking at low birth weight and previous history on the graph, and then over here I can just select different groups. Now I can add yet a 4th variable if I wanted. So let's maybe do race. So what is the chance of a mother with a previous history that was a smoker, okay, and was white? All right, so I held down the control button for that. I don't think that worked. Let me do this one more time. Let's take this off. I want to delete that. I want to say and race. Oh, that was right, I guess. So I want to say smoker and non-white. Again, holding the control button down. So now I can switch between whites and non-whites. I am getting some change here on the previous history no box. So if I go to non-whites here, you can see that jumps almost up to 50%. So this is called conditioning here. And with a local data filter, I'm able to condition on many variables at once. So in the notes there, I'm looking at the relationship between previous history and low birth across smokers. I can look at that across, here I'm going across ages. So with that mother's bin category. One thing that can happen is that if you condition so much, your counts can get kind of small. So here I'm looking at mothers between 30 and 40 years old that have had previous history, and then whether or not they had low birth. So you can see my totals are getting very small here. If I go all the way up to 40 and 50, I only have one woman in there. It looks like it's all white, so she had a low birth weight baby. She had no previous history, and I was 100% certain of that. But again, I only have one woman in that box or in that table. All right, so that does it for handout number 7, pages 1 through 10. And that dealt with conditioning and also the use of the local data filter. All right, thank you.